Okay, here is example 2 for probability models in our unit distribution unit. I want to remind you about our sum chart. So last unit we talked about things where we rolled one die, we rolled a second die, and we added those die up to see what the sum of the dice were. So for example, if die 1 was 1 and die 2 was 1, well, we have a sum of 2. We talked a lot about the different probabilities that could occur. So for example, what's the probability of rolling a sum of 7? Well, there are 1, 2, 3, 4, 5, 6 sums that equal 7 out of a possible 36 sums. So the probability of that would be 6 in 36. Well, now we're talking about a distribution though. And we're talking about the distribution for the different sums that are possible. That means that our random variable is the sum that we get on the dice when you roll 2 dice. So what is possible? Well, when I'm looking at my chart here, I see that I could get a sum of 2, that's numerical, or 3, or 4, 5, 6, 7, 8, 9, 10, 11, or 12. Those are all possible sums. Then when I go to calculate the probability of those sums, the sum of 2, probability of that, well, there's only one way to do it in 36 possible sums, 1 out of 36, 3, 2 out of 36, etc., 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 until we get down to 7. 7 is sort of a switching point because 7 breaks our data in half. There are 6 ways to get a sum of 7, but as soon as you go to 8, it starts heading down again. 5 in 36, 4 in 36, 3 in 36, 2 in 36, and how many ways to get a sum of 12? You guessed it, 1 in 36. Now I wish that we could be doing this lesson in class because there's a fun little exercise that I do on an Excel spreadsheet where I have you add your cases. I have you roll dice and add your cases to a master spreadsheet, and that may happen later. We'll see if I can get that to happen later, but for now I'll just have to show you what this looks like. So as a graph, ideally, or if you remember, what's the word that represents a probability that we have calculated, that we haven't experimented on, but calculated? And that is theoretical probability. Good. Okay, so if I wanted to show what this looks like in graph form, this chart, well, I've got a sum of 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Those are all my sums. And the probability up here ranges from 1, 2, 3, 4, 5, 6. 2 in 36, 4 in 36, 6 in 36. I'm not going to reduce those. I'll leave them as is because you can see this. And so basically when I look at this in graph form, it's just like a tent. We have 1, 2, 3, 4, 5, and then our highest at 7. That's where it peaks, and then it starts heading back down again at 8, at 9, at, oh, I missed it a little bit, but that's okay, 10, at 11, and at 12. Take off a little bit there. You can see though that the peak is up here at 7 because that's the most likely event to occur. It has the highest chance to occur right there in the middle, a sum of 7. You've got lots of chances for that.